Hi, this is Blind Man Bert. A friend of mine has a son who is now getting interested in doing some Unity, well, doing some game programming, and I recommended, of course, that they use the Unity game development environment, although there are other choices. And this is partly because it's so comprehensive, it's so well executed, and it's really low cost. And the motivation for the low cost, if you go to the unity3d.com screen and then you look at the different licensing, at first you might be kind of daunted for there being, you know, these $35 a month and $125 a month and contact us enterprise level things. I actually have a pro license. But really you can get very, very, very far just on the free license, and until you actually start selling games and making money, there's really no motivation or need to go into the plus or pro categories. One thing I would recommend when you're starting out is if you go to this store.unity.com page, scroll down the bottom, you're going to want to bookmark two very important links. This one down here where it says resources, older versions of Unity, and also Unity beta releases. So when you go there, you'll see that there are download links to all of the versions of Unity going back all the way to the old days of Unity 3 where I started. And the most current version of the final release, or the most current official release, is Unity 5.61, which was released in May 2017. We're actually at the crux of a major new release, coincidentally coming out, known as Unity 2017. And that's what all of these beta releases are about. You'll see there's the Unity beta program. I actually don't know if free folk can get access to the Unity betas, but if you can, I recommend it. We'll go through this in detail. If you go down to the bottom of this page, here it is. There's under resources here, you'll see older beta releases. So this is actually, I prefer just to bookmark these two pages. Unity3d.com/get-unity download archive, and over here unity3.com/unity beta archive. So in the description of this video I'll bookmark both of those links. The most current beta was just released today, and I just finished installing it, and I haven't really had time playing with it yet, but we'll get into all of that. When you download Unity, this kind of, like if I was to go into this thing right here, you'll see there's kind of like a lightweight installer right here. Download for Mac or download for Windows. When they just say get Unity, you're downloading the lightweight installer. That pulls in all of the individual components. If you ever need to reinstall a component, then you can certainly snag it in its entirety here. As we'll see, there's only, if you have the free licensing, there's only a small number of components you really need. All of these other components, Android, iOS, Apple TV, Facebook, and so on, those require licensing, so you have to pay money. So the ones that are free are, let's say I have a Windows system. I can support Macs and Linux development. So you would want to get the Unity editor, you would want to get the Linux and Mac components, and you would also want to get the standard assets, example project, and documentation. On the Mac side, you would want to get the Unity editor. You would also want to get Linux support. Windows support is down here. Standard assets, example project, and documentation. So if I'm doing my math right, that's a total of 6 components that you want to install. All of these other ones, if you install them, that's fine. They're just going to be sitting there teasing you with all these export capabilities that you're not licensed to do. It just eats up, I guess where I'm headed with that is it eats up disk space if you do that. So let's look at the, I'm not going to actually install it because I have the, I have it already installed. But let's look at actually, if you were to download all these pieces, what you would get. There are shaders, there's a cache server. I won't go into what those are involved, it's a little advanced. Here then are the various components that you tend to want, and here is that lightweight installer, which is shipped as a D image for the Mac. Here would be the exe, for example. So let me go ahead and snag that, open that, and let's actually kind of pretend that we were going to be installing this on the system. You launch it. Any security windows that come up you want to dismiss. And because my Mac is actually busy working on recovering the hard drive, in the background there's a whole lot of I/O going on. So anything I/O related that we do is going to be a little slow in this video. And there may also be little glitches, frame drops, and things like that. So we're just waiting for the installer to load. It's launching. And then we'll get into what some of the things I've done with Unity after this. Mock install. I'll show you some things we've done, things I've done. Still waiting for it to launch. Yeah, this takes a while. There we go. Okay, so now we're in the Unity installer for the Mac. This happens to be the Mac version, but it's going to be very simple, similar for Windows. You want to read and say OK to the software licensing terms. It's going to be free. You're not going to owe them any money. And then let's look at, oh, I accidentally left a few things turned on from the last side. So when you first launch this, most likely you will have the Unity editor, documentation, and standard assets installed. That's a pretty good minimum installation for Windows or Mac. But as I said, you have these compilation environments that are free into Linux, Mac, and Windows. So you should install those as well, so you can cross-compile whatever you build. If you build it on a Windows system, you want to get the Mac and Linux. Since I'm on Mac, I want to get Windows and Linux. And in addition, there's an example project that you should install as well. When you then need to put in admin privileges on the Mac. And then on the next side, you can run the installer. It'll just basically ask which hard drive do you want to put this all on. It's going to be, in this case, about 7 gig for these items here. Yeah, we need to wait for it. Apologies for my Mac being so slow right now. And you just want to hit continue, which would actually do the install, which I don't want to do because I already have this. Optionally, if you want, you can say advanced and then go here and put the packages in a custom location, like you can create a folder somewhere, and this would then capture all of the packages that were downloaded. So all of these things that we could download individually, you could, in the process of installing, you could have them saved somewhere in case you wanted to reinstall them. For example, just recently I found occasion to reinstall the example packages, and that's actually where we're going to start with my kind of talk about all of this stuff. I want to point you to well, first of all, if you select the examples project, you'll get this project. It's about 0.5 gigabyte in size that will be installed. It will go into a shared area in your users hierarchy on Windows and Mac. So on Mac it goes to users shared Unity. On Windows it will go in similarly into the shared user area under a folder called Unity. So that's where you want to look for it. If you look in there, you'll see there's a ton of assets. All Unity projects contain an assets folder and then a variety of other folders. We're going to actually open this up fairly early on when we first launch Unity. I'm not quite there yet. Going back in time, last summer, my daughter and I actually kind of had some training examples. We started first by kind of building a basic 3D scene with a bunch of basketballs and other objects around, as I recall, and then we added texturing, spherical texturing. We started with just, doing the basic editing, adding all the physics interactions. We then added texturing to the spherical objects. We started adding user controls so you could push these things around. And ultimately what we were starting to do was something that looked a little bit like a mix of, there is a standard Unity beginner project called Rollerball, and what we were actually starting to do was to build something on our own that was kind of migrating towards what Rollerball looks like. This is a very good entry-level project. Where you'll find that is if you're on the Unity website, you'll see Learn, and then there'll be a variety of tutorials here. Go into tutorials and you'll see the Rollerball tutorial here, which is kind of like discussed in 9 steps. That's a great way to get used to learning Unity. This is a great first project, but before you do that, you might want to go down here and look at the interface and essentials. That will get you really on board. When you first launch Unity, you'll see there's kind of like a, oh my god, look at all these controls. We're going to get there too. So in this tutorial series, I'm going to put a very brief version of the same interface and controls. So this was our first project, and the reason it's in separate folders, you don't normally do that with Unity projects, is because I wanted to lag each version. As we created a new lecture, I wanted to lag each version, so that's why they're separate projects. And we have videotapes associated with some of these. Some of the video was lost, so it looks to me like the only video that actually, this one was actually this video we have, but it turns out I was only looking at a few pixels of the screen accidentally, so all we have from this first lecture, from this second lecture, was the audio associated with that, and I'm debating whether or not it would be useful to post that. We do have the full video of this session here. It's in little bits and pieces, so I need to finish putting it together. Then we went on to build another project where we did a very simple 2D game using sprites. Sprites are kind of a new introduction into the Unity world, and it's how you do two-dimensional stuff. In the old days, as we'll see when I show you an example from when I tutored a 9-year-old 2 or 3 years ago on Unity, we used just simply 3D objects seen from a 2D perspective, and that's the way you used to do 2D. The whole 2D mechanism of gaming has been revamped, and it'll also be very exciting to see in the 2017 version what changes as well, because I haven't really played with that yet in the betas. So let me say that a couple of things. Actually, my history of this was actually way back when it was Unity 3. I was kind of mentoring a kid, and we didn't really do any serious development, but one of the more fun afternoons or weeks we had was in taking a very old tutorial called the car tutorial, which I'll actually run. And you'll see here, I'm kind of gradually introducing you to certain ideas. We see here we have the standard things in our Unity project. My sort of standard when I want to build a version, like for Mac or Unix or whatever, Mac or Linux or Mac OS, and I also have the iOS licensing, is to create a build folder, and then you would create whatever arbitrary target versions you want. So you'll notice this is there's a Mac version here, there is a Windows version here, and there is even a web player version here. So let's look at the Mac version, one of these. Oh gosh, this was in the days when PowerPCs used to exist. So I'm going to run the Intel version. This is just the unmodified car tutorial that existed back in the day, and I want to show you something about this. First thing is, and this is kind of common in Unity programs in general, when they first launch, they will ask you to set certain graphics settings. So they'll want to know how big do you want to make this. Do you want to play it as a window on your screen or make it full screen? I'm just going to make it a window on my screen, because honestly, if I don't, if it changes the screen resolution, that could mess with the recording being made. And this would be how hardcore the graphics would be done. Here you could say only show this dialog if the option key is down, meaning only show this, only ask me for this once, and then you have the option of holding the option key when you launch it. You also have ways of associating what are the various controls that are fed to the game. In this game, the only things that are significant are these horizontal and vertical indications known as up, right, up, left, up, and down in the code, and those are going to map to oh, actually, no, oddly enough, these map to the arrow keys, so I'm not sure exactly how that happens, that they map to the arrow keys. In any case, let's just go ahead and play this. We get a standard startup screen, and there's going to be a little noisy with the engine. So here's our car, and if we hit the arrow key, we're going to start moving forward. The kid I mentored and we played with this quite a bit just as a game. It's kind of fun. But I want to drive far enough to show you. I'm not actually going to race or anything. I'm just going to try and get to this point. Oh, I'm a horrible racer. You can see that there's pretty accurate physics of the car, really nice graphics. Oh, you know what? This is not even the top-notch graphics. Let me kill it and run it again and just amp the graphics all the way to the top. The graphics are actually really kind of cool. Let's do this again. So I'm saying fantastic rendering now. So on my i7 Mac, that'll just improve the quality a bit. I'm actually noticing the difference quite a bit. Yeah, this is a nice immersive experience. We get to drive this car, this little sports car around, racing car. Boom, I did the same thing. I took that turn a little too fast. Well, at least I'm consistent. Yeah, it's really hard for me to play from the keyboard. But I want to get far enough along to show you something. You can see you have, look at that, you have halo coming off the sun. You kind of get a lot of these things for free. Really great modeling, really an extensive demo. This is no longer released as one of the example packages, unfortunately, in Unity. One of the things we might try during this is to see if it'll open, being this old. Right after this bridge is where he and I said, you know, it would be fun, because we were talking about a lot of the modeling and so on involved in this. I said, wouldn't it be fun? Oh gosh, now I'm having trouble backing the wrong. Let me think about this. I want to back up like this, go forward like that. There we go, I turned into the right direction. So right around here, well, we decided, you'll see in this track, there's kind of like a city in the middle. Let me just kind of pause right here. There's kind of like a city in the distance, and you can never really get there because there's this fence. When you actually look at the model, there's an invisible fence that goes actually quite high. So he and I right here on the downside of this hill, right here, let me pause, we constructed an object, a plane of a given size. We added to this model, and we had great fun basically constructing a jump ramp right here, and we could jump off of this and go we would then, you know, we wouldn't die or anything, we'd go crashing into this valley, and then from there we could go around and explore the model of the city. So a great mod to be done to this model, and maybe I'll set a little lecture to see if it can be done, just to simply, even before you know about any of the, I'm kind of rolling down this hill, I'm having to keep backing up, but a great mod is simply to see if you can put in that ramp and then go wandering around the part. You can go all the way to the ocean, you can even all go to the you can go to the edge of the map, the model, and just fall off the edge. So there's this great world that you can't see, because unless you modify the model, you're trapped within those fences. So that's something we'll look at. So that's the car tutorial, very old. There's also a web player version, and the web player version, like all the Mac versions, you have just the application itself. The web player version, there's a plugin that you need to add to your internet browser, and then you'll normally, I just ran something with this, so normally you would get a click to enable the plugin. So here's the same thing at a kind of displayed at a kind of a lower resolution, but you can set the resolution of the player, and for whatever reason it's not connected to my keyboard, so this isn't quite working. I can't move the car. And then one thing I wanted to say in the Windows version is you'll notice the Windows executable file is actually really small, and then you have a whole bunch of data. This is because actually, regardless of which platform you're exporting your project into, there's actually a very, very small player, it's called a playback engine. And then what happens is the rest of the project gets compiled down into DLLs. All the code gets compiled into dynamically linked libraries, and then all of the graphics and the 3D objects get squashed they get processed into whatever is appropriate for the target platform. In the Unity application itself, and here's the Unity 561 folder, you'll see there's the application, and then you'll see there are the various playback engines, and I have the full set installed, although I'm not licensed for them except for the iOS and the free ones. We have here some standard assets. As we get a little bit further on in lectures, we'll see what those standard assets are. You can pull them in for free and start making use of them. I actually prefer to teach people to build your own early on, and then as you get more proficient, you can, if you want to pull in, for example, characters or vehicles or grasses or what have you, you can pull them in here. But early on, I think it's actually kind of a good idea to learn how to do them yourself, because that's what you'll be doing most of the time anyway. And then there's also some documentation here, as we'll see when we run this thing. Another thing I recommend is, again, like I said, the most current version is Unity 561, the most current formal release or final release. 561 F1 is the current final release. I usually have the latest betas also installed in parallel. And to have a parallel installation on Windows or Mac, it's really easy. The installer will always install into an application folder called Unity. So all you have to do is rename that folder after the install to whatever version number it is. And then, like, I installed this first, and then this came later. So then this installed into Unity, I renamed that folder, and just earlier today, I installed this. We are going to get to launching Unity, trust me, but I want to give you kind of like a roadmap of things I've done before then, because I'll be using that to discuss Unity. 2 years ago, I tutored a 9-year-old, and we took an old game when he was 8. We built a game conceptually in a programming environment known as Star Logo, the Next Generation. And then when we decided to make the graphics like really cool, I introduced him to Unity. But he was young enough that I think that exposing him to Unity right off might have been a little bit intimidating. But he took to it like a fish in water. He really enjoyed it. So this is his CreeperWorld. He did most of the design, and I did the scripting, because the scripting was a little bit so he decided what the game should be, how it should be played, and so on. And we can actually run this if there's a build folder. No, there's no build folder, so we can actually build this. This was built in, that will be our first project, is we will launch Unity and we will build CreeperWorld. So you see how there's no build folder here. And in it, there's a player named Steve whom you control with your keys. It's a two-dimensional game. There are these 4 creepers that just come in, and they're the things you want to avoid. They're just constantly going after you, and if they touch you, if they catch you, you die, game over. There are also these 20 white cats, and what you want to do is you want to go around to snag save as many of the cats as you can. If the creepers touch the cats, or the cats touch the creepers, then some of the time there's a probability of about 1 in 4 that a cat will become another creeper. So it gets worse the more creepers there are. And then that's all controlled by scripts which determine what each character is doing. And we'll look at this in detail as part of this training. This is a really great training example because it's so small. And then we have here the camera controller, which simply says whatever it's optional whether or not you want a camera controller. You can just have a fixed camera sitting somewhere in the scene. But if you want to have a camera controller, you just simply say, pick which object it is you want to follow, and then the camera will always track it from 10 units above. So you can think of this game being 2D as existing in the XZ plane, as we'll see, with the camera being like on an animation stand sitting above in the Y direction, in the up direction. There are also materials associated with these things. We snagged a whole bunch of PNGs and JPEGs from the internet to represent our individual characters. This will be more obvious if I go to a larger. So we snagged a whole bunch of different creepers, Steve, a bunch of cats, and we used those as the basis for establishing the characters. We then created materials. A material is something where you take a texture and then you define the full material with its specular lighting properties and so on, bump maps and so on. So a material takes a variety of textures, puts them together, and then you can use it to paint objects, spheres or cubes or planes or whatever you'd like, polygons, polyhedra I should say. And finally we have one scene, as we'll see. Last year, as I said, what my daughter and I did was we started with this this 3D game, and then we also explored sprites for the first time in Unity 5, and that'll be later on when we talk about this. So let's go ahead and launch Unity 5.6.1, and we'll launch this, we'll open this project here, the CreeperWorld project. So when you first launch something, you'll have just, if you've installed the standard assets example project, you'll have just that available. We'll look at that in a second, actually. Let me go ahead and open up CreeperWorld. You could get to it here. You'll see where it's... Oh, you know, the other thing I wanted to mention is in the old days, I used to keep all my Unity projects as part of my, my user hierarchy on my Mac. And then this would normally go into like BERT Unity projects or something like that. But I actually like to have it in a development folder and then Unity projects and so on. More recently, though, I realized it was actually kind of better just for my file management to keep it in a shared folder, kind of like where the standard assets example project is. So that's why there's this split, why the newer games are ending up here, or the newer projects are ending up here, and the older projects are ending up there. You have your choice of where to put it. It's just how much you want to share it. So let's, the other thing you could do is you could potentially open it this way. If it's not listed, just press the open button and you'll find it. This is looking at my local project folder. You could also go up, and in the shared folder you would find the shared projects out here at users shared Unity. So these are the shared projects. So let's go ahead and open CreeperWorld. I've clicked on it. Being file related, this could take a while. There's kind of like a re-importing process that can happen. If you've previously edited this project using an older version of Unity, then you'll get a note, a message saying, oh, you're bringing in an older project. And here we go. Here's our first view at what Unity is all about. This is where the user interface tutorial comes in handy, and I'm going to just very briefly say that you have a number of panes that you can see. In each scene, this is kind of representing in the current scene. You could have multiple scenes. There is a camera. There are a collection of however many that is, probably 24 cats. 20 cats? 4 by 5? I can't even see. 20 cats, I think. You have 20 cats organized in a little grid here. You have Steve here. You have the creepers out here. When we press play on this, these actually will get spread out to their starting positions, and now the game is playing and I can go snag cats and avoid the creepers. Oops, I died. So we can see that within this game view, this is viewing the scene from our camera situated above this flat plane. We can actually launch the game and play it. In addition, what's really nice is you can stop and look at, okay, where's the camera right now? What's the state of this cat? There's, you know, we can go over here and look at all the various things. We can single frame it, so if you watch the position of the cat and its the direction that it's facing, those things will change as it moves. So the cats are moving, as is everything else except Steve, because I'm not pushing him with the keyboard. We have these 4 creepers. We have a light source. That's very important, and we have the player Steve in the middle. If we look at the player, we'll see that there's a variety of components. So some of these are related to how this is being rendered, what type of object it is. It's actually a very squashed cube. Objects in Unity, game objects always have a transform component associated with them. This is basically their orientation relative to whatever coordinate system they're embedded in. How can you have embedded coordinate systems? Well, since Steve is at the top of this hierarchy, he's embedded in the world coordinates of this frame. So this is defining where he is, which way he's oriented. We'll notice, for example, if I spin Y, that's going to change. Well, you can't really see it because of the way this camera is kind of zoomed out. But if we spin in Y, oh, there we go. You can see he's turning up and down, and 180 is kind of the spin we always want to have him here. X and Y would be his location this way in X, Z would be in this direction, and then Y is coming to the camera, but it doesn't really look like it's moving because, as it turns out, we have an isometric camera set. Somewhere in the camera preferences, we have orthographic projection. So this is a isometric view, not a perspective view. If we switch it to perspective, oh, now things get really messed up. I don't want to do that. We have more of a depth queuing camera, and things are set such that when you do that, it gets really messed up. Okay, so I'm not going to bother putting Steve back where he started. That doesn't matter. Let's talk about asset management. Oh, we have a little bit of an error. I'm not sure why that occurred. That may have had to do with me fiddling with how high up and down this this object was. Not sure what happened there, but that's to our console, and we can just clear it. Good. It's good to ignore errors every once in a while. Let's talk about asset management. So this is a scene in our game, and it's basically a hierarchy of objects. It actually corresponds to a file in our hierarchy called scene 0. If we go back to our files list, that's this folder and this file here. So what I like to do for smaller projects is simply have folders for each type of thing that I'm creating. Okay, and then there's a folder called scenes where I have different one or more different ways of placing them in the scene. And then as you build out different things like materials here, you would create a folder for that. Since textures are almost always associated with materials, I like to put the textures folder within materials, just simply because it's kind of closer, not its own folder. These are the 4 scripts. These species, that's kind of the word species, kind of holdover from Star Logo The Next Generation, the way that worked. There's only one Steve, so we don't need a species for Steve because there's only one object of him. But it makes it easier to create like armies of things, like 4 creepers or 20 cats, if you create just one creeper or cat and then use it as a prefab to duplicate all the rest. What's nice about using a prefab is we can go down here and change things for all of the cats, right? Well, in this case, the creepers. We could go in here and change all of the things for cats if we'd like. Like we could change what the image was and then say, okay, push that out onto all the cats. Or conversely, we could go into individual cats, customize it, and then say when you're editing a particular parameter, whether or not you want that to stick for just that cat, or whether you want to pull in parameters from the prefab. So this allows for customization as well as kind of organizing things so that you can create these armies of things. Also handy for when you want to have just like lots of things like missiles that you can pull out, and you want to have a lot of missiles going. You can have them all prefabricated, and then you're just pulling them out and running them, or they can be created on the fly. Objects can pop in and out of existence. So for example, as the cats die, they actually die. They disappear from this hierarchy. As Steve collects them, they die, or as creepers run into them and they get converted into creepers, they die as well. So this is basically all about asset management, managing all of these are files. These are memory-based objects, so these are things being pulled out from this scene and creating memory. When you press play, an interesting thing happens where that initial hierarchy gets cloned. So actually, if we go around and start collecting cats, we'll see the list of cats on the left is changing, is getting shorter, and that's because the cats are being sucked up and some are being converted into creepers, and others of them, you see how there's only 2 cats now. Now there's only 1 cat, and if I go and capture that 1 cat, boom, you see all of the cats have now disappeared from our hierarchy, and we have it's only showing the creepers that are part of the creeper hierarchy here. These were actually dynamically created, cloned from cats, and we'll see how that works in the and we didn't bother to place those into the creepers hierarchy. There's no need for it. This hierarchy, in fact, of cats and creepers. This is just simply for organizational purposes. But you'll notice when you create something like this, there is a transform associated with it. So conceivably, if we spin the cat's group here, they all share the same coordinate system. So you see how this spins all of the cats, or if we orient it on the 0 axis. This is because we have a kind of a container relationship. I'm kind of all over the place in talking about this. I don't know what to prioritize first, but the way this is done is you can create, if you go here and you say either create empty, or you right-click here. We have to have nothing initially selected. You right-click and you say create empty. You're creating a new game object, which you could say is a new container for things. Okay. So for example, if we put Steve into it, and let's rename Steve to Steve just to make it clearer. Okay. Now we could individually rotate and move Steve, but in addition we can rotate the container he's in, and you see now because the container is oriented with a different center than the rotation gets weird. So you just have to kind of think about what this is. See that weird rotation? So the center of this container is somewhere down here, just because of where we last clicked. Okay, I know what I want to talk about next. And any of these things, you could have a script associated with just the container, or you could have a script associated with these things. If we actually look at where, let me delete this thing because we don't really need it. If we look at Steve, we have the things that make him a squash cube. And by being a squash cube, I mean he's scaled weirdly. He started out a 1 by 1 by 1 cube, and then we squashed him in the Y direction to make him very, very thin, like a piece of paper. And then we stretched him in the X and Y direction to kind of fit this grid where each thing has a 10 by 10 kind of unit. Again, we're looking through the game view, we're looking through the camera. There's also a scene view, which may make it easier. You can actually create many, many scene views. You don't need to settle on one view. I think that's done through here. Add tab, and you can add another scene view. So we could create another view looking from a different perspective here. And if we put those tabs together, now we have ways of kind of cutting between those different scene views. Now we're getting into kind of the area of customization of the layout of your user interface experience. And I want to talk about that kind of very briefly. Here's the scene view that was kind of built for us when we opened this game, and we have controls here that let us change. The hand view here lets us pan in the direction of whatever. It's kind of like a virtual camera here. It's not this camera, but we're seeing it from a particular position. And if we just simply grab with the mouse left, right, up and down and drag, we're going to be changing what we're looking at in whatever plane this is. Okay. If we want to pivot around a given point, we can hold the Option key down, and now whatever is considered our center point, we're pivoting around. If we wanted Steve to be the thing we're focused on, we can double click on Steve here. That brings him front and center. Now we're pivoting on Steve. And if we truck. If we truck left and right, or go up and down, it's starting from where Steve was. Okay. So now if I do this, our pivot point is no longer Steve. It's somewhere down here. I can go on Steve again. There's one third control, and that is, we talked about trucking or translating left and right. Translating is a bad word, as we'll see. We saw about pivoting by holding the Option key down. There's a third thing you can do, and that is you can zoom in and out by using the scroll wheel. So now I'm scrolling back. Now I'm scrolling in. So we have all of those controls, and you can change what you're looking at. These are controls that are independent for each view. So, what is actually the center here is the origin, and you'll see there's a kind of a there's a kind of a thing that looks like a sun. That's actually our light source. Our directional light source is not, because it's directional, you don't need to, this is kind of an odd thing about this type of light source. You don't need to pull it up. It's just showing you a vector direction that the light is moving in. So I have it positioned at the origin, and rotate it in such a way that it's pointing straight down in the negative Z direction. So basically light comes from an infinitely far light source above, goes down and hits the XZ plane, and then is headed in the minus Z direction. We could change its color if we wanted, or everything would become pink and weird. We could turn it on and off. Because we're looking in the scene views, it's not affecting anything, but oh my gosh, it would affect things in the... It didn't affect things because... Oh, I didn't turn it off, in fact. Yeah, so you see how everything becomes dark in the... Oh, it also becomes dark in the scene views. Yeah, so if we turn the light off, all we have is kind of like there's an ambient light setting, probably set in the camera. You have a certain amount of ambient light being set, or in the preferences you'll have, I forget what preferences are, graphic project settings. You'll have some lighting defaults there, so you can tinker with all those things. There's a lot to learn. There's a lot kind of going on. You notice also there's a 2D button in these scene views. That's because we can. It's unfortunately selecting the wrong 2D view that we want. It's selecting the wrong plane. But we can also click on these things. Y would be the one. So this is now looking top to bottom in perspective. And if we wanted to, we could go isomorphic by, see how here you have kind of a thing here that shows kind of perspective lines. If we click on that, now we're looking orthographically. So this is actually more in line with what our camera sees, except it's centered at a weird point. It's centered on something near Steve, not quite Steve. We could do that obviously with any of the other views. So that's in a nutshell kind of like basic controls. I mentioned that we can customize our layouts. You might want to explore excuse me, what some of the different layouts are by going to Windows Layout. So for example, you have 2x3, so you'll see a scene here and a game view there. Here's your hierarchy, here's your project kind of hierarchy here, here's your inspector. I don't think I could work with that layout. Here's a 4-split. This is handy when you're doing real sensitive modeling and placement of things. You can see a perspective view here, and then by default whatever you're looking at is being seen in perspective. These are set to be perspective, but you could click it into orthographic if you wanted, along X, Y, and Z. That's a handy one for doing precision things. Here's a custom one that my daughter and I were using for a while. I think the only real difference from the original is there's an extra project. Oh, I remember why we did this. We liked having an extra project thing here, so you could simply easily drag things from one place to another. So you could simply move things and take it from here to here. It's not. Oh, and there's also an animation tab here. So that was kind of the customization we added. Then we have tall, which is handy for seeing more of your scene or game in a tall representation. So this would be closer to the aspect ratio the game would actually play at. And wide, which is kind of getting it more this way. So you have different ways of organizing this. When you read the documentation, you'll see all of these things are customizable. You can move around the panes, you can delete them, you can create, you can split. Like I could split this in two if I wanted to, and then once you have that up here, you could make that a new layout. So you can customize your layouts. We were starting with just the default layout, this one. In this first lesson, this is probably, oh, I want to go actually a little bit deeper and say, we looked at the scene hierarchy, which is right here. Let's talk now about the materials that were created. So for example, the cat material. The cat material is a very simple material in which we simply took a JPEG file, this one, or PNG file, the cat2, we called it a texture, just to make it clear. We kind of have the standard where we put in like underscore this to indicate what it is. So this is a texture, it's just a two-dimensional image. Ideally you would want it you would want these areas out here to be transparent. But since we're not really concerned about that in this game, we make just square icons. We wanted this to kind of look like an 80s game, so very simple graphics. So we downloaded a whole bunch of cats. We downloaded a whole bunch of creepers. We found a good Steve. Max was then the art director on this project, and he decided how this would all work, and he actually constructed the materials. He created these materials. We named them all according to that convention. So here's the cat material, the creeper material, and then the Steve material. And then all you have to do to have a creeper, you see like a creeper here is associated with that. If we wanted a particular creeper to look like Steve, we would simply have to drag this material, and now that creeper looks like Steve. If we go to our game view, lo and behold, there's a creeper that behaves like a creeper but looks like Steve up here. Okay. If we wanted to create a new object, that would be very simple. Either in our scene view, we could create, well, no, not in our scene view. In our hierarchy, we could create another cube in this case. This was made before sprites came around. This was made in Unity 4.5, so I'm kind of doing it the old way, the obsolete way. In the new way of doing things, you want to learn how to use sprites. But in the old days, what you would do is you would create a cube, and that came up unfortunately inside a creeper. So let's move it out. Let's call it a new thing, or new cat, because we have plenty of cat materials. So let's say that's a new cat. Okay. To get it squashed in the same way, let's see where it is in our scene view. In fact, let me get further back and kind of pivot like so, and get further back even still. Where's our new cat? Our new cat is kind of hard to see, but, oh, because it's at position 100. Let's move it into 0, 0, 0. There's our new cat right there. We're going to raise it up in Y. So, oh, that's rotation. Let's just rotate it to 180. Raise it up in Y. So we're going to increase Y. There's our new cat. And without this squashing, it would be a teeny tiny cube. Like 1, 1, 1, it's a teeny tiny cube. If I went 10, 10, 10, it would look like this. So far, there's only the default shader, so it's actually doing a kind of a rendering job on this. What I want to do is I want to squash it down to just being like a little tile. So there it is. And let's move it, we'll move it a bit to the left. Let's say minus 40, minus 50, minus 60, there we go. And Z is fine, and we'll put it flat with everything else. So it's over here, kind of move to the left, flush with Y. Let's move it also in Z. Oh, that's up, down a bit to minus 40. That's too far. Minus 30. Oh, I said minus 30 by mistake, so it didn't take. There we go. So we'll put it right there for now. Let's get a little closer to it so we can see what's going on. Okay, so there's our new cat, and we're going to make it look different than these cats. So we've done the first thing in that we've created a cube, squashed it down here. We don't care about all of these things here, although, well, no, we do care about these things here. Let me talk about what these components are. This is what fundamentally makes it a cube, is this mesh filter. And this mesh renderer is what then makes it visible on the screen, subject to lighting and these other things. But fundamentally, this is the shape this object has. We also have a collider object coincident with it. It happens to take on the same shape. The collider is important because this is how you can detect when collisions have occurred between it and other objects, or maybe you have a door, you want to know what things have gone through the door, so you put a plane right there, have those objects collided with that detector, that wall plane, if you will. So the box collider is going to get involved in the scripting, as we'll see. As yet, we haven't made it behave like a cat. We're gonna head there in a moment. But first, we need to take a texture, like we'll take this one, Cat 7. I kind of like. We're going to create a new material for it. So in the materials project management, either up here under selecting this folder, either up here under create material, or over here right clicking create material. We'll create a new material. We'll call it cat7 mat underscore mat to indicate it's a material. So you can see it comes up with all sorts of defaults, very generic defaults. We also see it being this material being mapped on a sphere, but down here we have a control. Ultimately we want to see how it's going to be looking like mapped against a plane, but for now let's keep it as a sphere. Up here where it says albedo, that's where we can associate the texture with that. So if we click on this little circle right here, we could make it simply monocolored, and that would change the color of the material to just be a matte, whatever color we want. Okay, but to associate this texture with it, I'm going to click here on this dot. This brings up all our textures, and we see cat7's over there. So double click on cat7. Cat7 is now wrapping around this, and if we drag this onto the new cat, we'll see we have a cat. The lighting is such that it's coming up kind of bright, so that's something we could actually maybe downgrade if I think about it. We would also like to see it here not be projected against, not being mapped onto a sphere. We would like to see that texture mapped onto a tile. In terms of making it darker, I don't know how I would do that. Oh, this smoothness seems to make it a little bit more visible. I would have to relearn all these things. If you want to make it bumpy, if you want to make it look more detailed, you would add additional textures for those bumpinesses and so on. And you can read up, on any of these subjects, whenever you want to get the corresponding manual page, you'll see there's a book icon here. Just click on that. It will take you to that section in the embedded documentation that was installed. It will take you to the corresponding manual page, which is a very handy feature. You'll find that throughout. When you're looking at the inspector, you'll find tons of these. It's very handy. Can you do that on an individual thing? No. It would have to be one of the things described as a topic inside the this thing. So we've done all those things. What we haven't done though is we haven't made the cat behave like a cat, and to do that we have to go into our scripts, take the cat controller, drop that on here. Now we see the cat controller script is in place, and there's some things that we need to set about cats. These are parameters in our code, as we'll see. One is the speed. So let's see how a typical cat might be set. This cat is moving pretty slowly at 10. It starts out with a neutral heading, and it can go out to 100 units. So 10, 0, 100 are kind of our neutral things. Let's make this cat move considerably faster. The heading won't matter, as it turns out, because that's initialized when you start the game. The headings all get reset. And let's say this cat can wander out much further. It has a range of 300. So if we do this, let's play the game and see what happens. Oh, we have to be in the game view. Yep. So there's look at our fast cat. See it moving? Let's go chase it. We interestingly can't catch that cat, and I'll explain why we can't do that later. Actually, yeah, there's something I forgot. Forget the fact that Steve's a little tilted over and there's a Steve chasing me. The reason that failed to act as a cat is I forgot here we have to put it in the cat. We have to tag it as a cat. That plays into how the scripting is done. Let's try that again, and we'll see. Now now that cat is at a different location. So yeah, I don't know. Let's do it again because I didn't see where the cats get randomized. Look for the fast cat. I don't see it. Yeah, and I think the creepers are getting it. In any case, I'll do it one more time, just hopefully to catch that cat. I still don't see him. Don't know where he's at. Anyway, that's kind of how you can modify this game on the fly, which is kind of cool. Now these scripts, I prefer the C# language. JavaScript is also commonly used with this. They both build to the same type of DLLs. In terms of execution speed, as far as I know, there's not really any difference. But I prefer the C# language. It's one of my favorite languages. So all of the coding I do, I kind of insist on being in C#. Let's look very quickly at these scripts, and then we'll be done with CreeperWorld. If you click on a script, you'll see it kind of squashed up here. This is not a good way to look at it. But if you up here, you, no, not there. If, that's on Steve, so here, if we go here and we click on this gear, you'll see there's an edit script. Or if we simply double click on this, this will launch the Monodevelop editing tool, which is the editing environment for C# and JavaScript. It's also the compiling environment. This is a bug that has started. It's a benign bug. A more serious bug is when Monodevelop crashes, so I'm not sure why that's occurring. Let me quit out and see if that's just, I'm not going to save any of these scene modifications. Let me see if that's just this recent installation of 5.6.1, or if this is going to occur on all my versions. Let's launch the most current beta, 2017 1.0 beta 10, and let's launch CreeperWorld. Now here we see that since the last editing environment I used to play with CreeperWorld was 5.6.1, it's saying, oh, that doesn't match the current editor. We're going to have to convert things. We're going to have to re-import everything. Do you want to do that? And the reason this is important to know is if you save anything, you can't go back to that older version. So you can only move forward as you do these conversions. So I'm going to go ahead and re-import, but I have to remember not to save if I want to maintain compatibility with that older version. So it's re-importing everything. Let's see if I can open that script. It'll be kind of a drag if I can't. So here we are back in our project, and what I want to do, there's a little error involving some asset refresh. I'm not sure why that is. Let's see if I can open this player controller. Hopefully I can. There has been a problem with this project in particular. I don't think it's my Unity 5.6.1, but in general I've been having trouble with CreeperWorld. I've noticed recently. Yeah, see, that time it worked, so I don't know what the story is here. But I want to talk very quickly about these scripts. We have the 4 scripts here. Player controller is actually this one. This looks complicated, but it really isn't. Those parameters we saw before are there in our script. If I select the player, we'll see this in the background. So remember we had these, well, we didn't really look at the parameters for the player. We were looking at the parameters for cat. But each of our species has different parameters, or we should say fields, associated with the member fields in the programming sense. Those member fields are not defined over here. They're actually coming from the script. So whenever you create a public member field, that puts it up as something you can change over here. So that's where the speed, the alive Boolean comes from, whether it's alive or not, and its current score, which is the number of cats that have been created. So there's always a start method, which gets called once when you hit when the game begins, or here in the IDE when we hit the play button. So all this is doing is regardless of what our initial position is in our scene editing, we move it into the 0 point, the origin. Vector 3 is a class for 3D objects, 3D points. There's also vector 2 for 2D points. So we're simply saying here, move Steve to the center of the coordinate system. Steve is alive. He has score 0. So that's setting initial values for this. If we run this and then immediately pause, we'll see here, look how his coordinates are at 0, 0, 0. We moved him to the middle. We didn't change his scaling or rotation, we just changed his position. That's actually an important point. Notice how we just changed in his transform object, we changed only the position, not his rotation or scale. Then here, on each update, this is on the, oh, and then we set also oh, we didn't set his speed, so this is actually a dialable parameter. So this would control the relative speed at which Steve moves. And these are all values fine-tuned by the very brilliant game designer Max. When he was 9 years old, he said, okay, this should be this fast, this should be this fast. So he was setting the speed. I don't think he fully appreciated that you wanted to have the variable but not initialize it here to allow that kind of tweaking to occur. Here in the update method, this is called once per frame, and one very subtle thing I'm going to point out towards the end is the frames are not necessarily hitting at equally spaced time intervals. So down here, everything is scaled according to time.delta time. That's kind of like in math terms having a dt to say, well, for this much in what you're updating, you have to have relative to time, relative to dt, you have to do this. So all that's occurring here is I'm creating a little vector. I'm then asking the input system, are there any keys down? Up, down, left, and right are the only ones I'm sensitive to. Or some combination. You could have up and left both down, in which case you'd be moving at a 45-degree angle. So if the up key is down, to my direction add the up unit vector. If my down key is down, to my direction add the back. Down would be, yeah, you see how the forward, up and down and left and right are the up and down and left and right keys. Here you have to be conscious of translating them into the appropriate units based on the fact that you're on the XZ plane. So there's no reference to up and down here because that would be the Y direction. That would be the camera direction. So left and right makes sense. This is the X translation occurring. So these two make intuitive sense. But forward would be plus Z and backward would be minus Z. So up translates to plus Z and backward is minus Z. Then the really important statement is this one right down here. If we're alive, we can move. In order to move to our transform, we translate by a certain delta. The delta is our direction, that's this vector here, multiplied by our speed, modulated by our speed, modulated by or multiplied by the dt, the amount of time that's passed. So this is going to create a frame by frame change, and then you just have to scale this parameter so that you get a reasonable time. And this is in the coordinate system relative to the world coordinates that Steve is embedded in. So this is saying we are doing this in world coordinates, this translation. The cats have a similar definition where there is a speed and a heading and a range. The speed is again the relative speed that Max fine-tuned. The heading is simply a value from indicating negative 180 to plus 180 most likely, which says which direction they're heading. And then we also had to put in a range parameter to prevent them from just going off into just infinitely, and then you can never catch them. So there's a slightly different initialization that occurs here where we're saying find a random position within the box bounded by within the rectangle bounded by that range, put them there and make their heading be a random heading between minus 180 and 180. So at the start, each cat is simply put in a random position within that box that bounded by the range parameter and put them in a different direction. Here, what we do is we add frame by frame a random tweak to their heading, which this is Brownian motion, so this is saying they're going to kind of wiggle a little bit as they move. If the heading happens to go over 180, correct that by subtracting 360. If the heading goes below minus 180, correct that by adding 360. So basically this is just simply saying tweak the move a little bit and make sure that the heading is expressed as an angle between minus 180 and 180. Then, and this was way beyond, this is stuff I wrote, this was beyond what Max could handle at his age, we have a little bit of trigonometry here to say which direction they're moving based on that angle. And that's simply because, unlike Steve, who can go in units of left, right, forward, and back, discrete units, discrete vectors, the cats can move more in a continuous vector, a continuous direction. So there's actually some trigonometry involved, but you see the same modulating parameters here, times speed times time dot delta time. and that's what then does the frame accurate thing. Without time.delta time added, you can end up with choppy motion. So it's important to get in the habit of always having time.delta time on your things here. And then here, if it goes too far away, if it exceeds the range, just flip it around. So it's turned. That was our simple solution without a whole lot of work. Just simply, if it goes outside that box, if we detected it, we could have done this with a collision with the box. That would be fancier to have a fixed box, but it was easy enough just to say if the X or the Z coordinates exceed that bounding value, flip it around, and then it would tend to go back in. So that was enough to keep our cats contained. Creepers have a very similar definition, although there's one new thing about a creeper which we should talk about. We're just talking about the member fields, the start, and the update. You'll notice I'm avoiding on collision enter. I'm going to get to that in a second. The way a creeper works, let's pick a creeper. The creepers and the camera actually have something in common. If we look at a creeper, we'll see that the parameters of the controller are a speed, and that makes sense. It's a weird speed in that it's kind of like some non-integral value. I'll explain why that is. And then there's also a target. We can make a creeper target any playing object we want. So we could say, you know what, have this creeper follow cat number 20. Now this creeper won't be going after the human anymore. In fact, if we release this and let it play, there's going to be a creeper. I can't see it, but there's a creeper that's going after a cat. Oh, this collection of creepers here all were not headed. See how they're not headed towards me? They were going after some cat. In fact, they turned that cat into a creeper, and then they all just kind of bunched up around it. So we changed the behavior of that one creeper to attack a cat instead of us. That's how easy it is to change things, change relationships. So we have those two things. We have the speed and the target in our creeper script. So we go back into Monodevelop. Let's see how that works. Here's the speed. Okay, this looks uninitialized, but is manually tuned, as it turns out. We'll see why that is. And then we have here, that comment is kind of important. Here we have what it's going at. Here we have a private constant, a floating point value called the cat conversion probability. And Max liked cats to be converted by the creepers at a high rate. I would have put this at a lower rate, like 1 in 10 maybe that would happen, but that's okay. That was just his game, the way he wanted to do it. We had to fix an important problem that we didn't really realize would occur when we built this. If we simply set all of the creepers to the same speed, then what would tend to happen is they would all tend to stack together and follow you as one. So it was important at initialization to randomize the speed. So whatever the speed of a creeper is set here, you'll see we have 15, 15, 15, and 15. So the speed is initially 15. It was important for us to randomize a little bit so that the creepers would be plus or minus off from that to prevent them from stacking up and attacking you together. As they convert, when they convert cats into creepers, there's another issue because you'll see we basically make the cat disappear and we clone the creeper at the position of the cat. Ideally, that cloned creeper should also be slightly randomized in its speed as well, just to prevent similar things from occurring there. Like in that example we just run, you saw all the creepers were kind of moving together as a horde. That's because those were converted cats and we weren't kind of tweaking those speeds a little bit. So there's all kinds of little subtleties like that that come up when you design a game. In terms of what the update once per frame thing is, note again we have the same kind of modulation going on here with time.delta time. You need to get in the habit of doing that. A scalar times dt is what that means in a math sense. So this is actually very easy to understand, considering that if we have a target, we're going to move towards it. This is simply a programming fence allowing for maybe we didn't set anything here and it's null. Well, we don't want to feed null down to this thing. That would make things crash and break. So this is simply saying as long as the target is non-null, if we have a target, then figure out the vector towards it and scale it by speed time dot delta time. That's what our position wants to be. We want to move along this vector from where we are towards our target's position scaled by this. So what's this doing? What this is doing is this is simply computing the vector from us to the target and then taking just a little piece of that vector, the speed times dt component, and that's what then determines our new position. So we're basically going to be point by point computing that vector and moving in that direction. Now it's time to talk about the last method in our species. Let's actually talk about the camera controller. Let's not leave it out. Camera controller is very simple. It's based on the creeper actually, and there's two parts. There's either an on-off, whether or not you're tracking, and then what you're tracking. So if I turn it on and then we run this, we'll see a slightly different behavior in the game. Now as I move around, you see how it's keeping the player in the middle as opposed to before keeping the origin in the middle. So this is a little Boolean that you can turn on and off to enable that behavior. The way it works in the code is this. Here's our Boolean. Here's the object we are tracking. Okay? We don't need to initialize anything because actually these have to be set in the IDE. We have to set whether or not we want to track. We have to set whether or not there's an object we're tracking. So in our once per frame update, what we're doing is if we're tracking and we have a tracked object, this should really read the other way to be clearer. This should be really this, just in the interest of clarity. Oops, that should say tracking, not trackinging. Hard to type with one hand. So if we're tracking and we have a tracked object, then what we do is we simply take the tracked object's position, we add 10 times the y unit vector up, and that's the position of the camera. The camera has to be set up to be pointing down, and that's what's occurring here. But then whatever position this is, that's going to be determined at runtime. We're going to blast out the position, and we're simply going to compute it directly here. So that's actually a nice change. I'm going to save that change. Let's go back to the player controller, and we'll now look at the collisions. Because each of these objects have colliders, and the colliders are enabled, when these two species or when these two objects meet, that will trigger an onCollisionEnter method call. If you have onCollisionEnter enabled, then what occurs is you determine what to do. So first thing we want to do is a message is kind of being passed about what the collision is all about. One of the fields of that is a reference to the game object that we're colliding with. Here's where tags play a role. Remember that cat didn't behave as a cat until I said tag it as a cat. So we say, what's the tag on the other thing we collided with? Is it a creeper? If it is, this is just issuing something into the log saying we collided with this. Tag is us, that's our tag, like player collided with creeper. Alive goes to false, and then we set something that actually triggers something in the GUI to show that we died. I'll get into that in a second. Otherwise, the other collision that's significant is if we collide with a cat and we're alive, meaning we're still able to play. It's not like the cat ran into us after we died. If we're alive and the other thing is a cat, then log player collided with cat. We get 1 added to our score. So this field up here bumps up by 1. And we destroy the other thing. We destroy the cat. So the cat dies in the process of our saving it. That's how we remove it from the scenario. So it's this, plus the fact that creepers will harvest cats as well, that causes them at runtime for the cat objects to disappear. So that makes sense, right? Let's look at how the creeper controller works, because it's pretty similar. On collision, remember we're now looking at how a creeper handles collisions. So if a creeper collides with a cat, log that we collided with a cat. It will say creeper collided with cat. Now we look at the cat conversion probability, and we generate a random number in the range of 0 to 1. If we're less than or equal to that probability, roughly 1/4 of the time, we will convert that cat into a creeper. First thing we do is we snag where that cat is, because we want to have the new creeper created at that location. We destroy the cat. We then clone us as a creeper, putting the new thing at the position of the cat and the rotation of the cat. Okay, so it's actually a really simple code. You just simply have to get to the point of exploring what things can I do, what are the methods, and that gets into a topic of scripting, which is beyond the scope of this bit of a lecture, and that then shows you how that all works. Is you learn, oh, when I clone something, what are the arguments to how I clone? Oh, I simply have to say put it here. I want to say where it is in position and rotation. Another possibility is that a creeper will collide with the player. As it turns out, the player collision code handles everything we need to deal with in regards to that. So aside from logging it, we don't do anything. And finally, there is an on-collision. Oh, there doesn't even need to be an on-collision enter. I was speaking too soon. For a cat. The cat just basically goes along, and other things, other forces determine what happens to it. If we wanted to be a little bit cleaner in the code, we could say the cat destroys itself if it runs into a creeper. However, then we'd have to deal with the possibility that the cat might destroy itself before the creeper can grab its position. So that actually might not be easy to code. It might be easier just to say, you know what, let the creeper handle what happens when it runs into a cat, whether it's going to leave the cat alone. In other words, if this number comes above 1/4, like let's say it's 0.6, we'll leave the cat alone. But every so often, if we run into a cat and this number happens to be in the right range, cat dies, we create a creeper. You'll notice also there's a little bit here related to onGUI. This is related to an old defunct. This is actually what's generating this two-dimensional display up here, the score display. And so I don't really want to go into it because it's obsolete. But suffice to say that this bit of code, let me pause this, is what is showing 9 cats left, 9 cats caught, 14 cats left. And then when a creeper runs into me, if I just stay in the middle and don't do anything, 0 cats caught. Now cats are disappearing as they get converted into creepers, and game over, play again. So all of that is being controlled by this onGUI thing right here. Here's the number of cats left. We're counting up. We get a list of all of the objects with tag cat. The length of that list is the number of cats that are left. This is frame by frame, keeping that GUI box alive, showing the score and the number of cats left and so on. In order to deal with the plurality of cats, I defined a little bit of a method here, which simply says if there's only one cat, the string that you should use to describe that cat is cat. If there's more than one, if there's 0 or more than 1, you should say cats. 0 cats, 3 cats, and so on. So that's just dealing with the plurality. That's why you have cat string. This is taking the score, the number of cats caught, and converting it into a string. Here then is the code that then says whether or not the game is over, whether or not to say the game is over. If you're not alive, or cats left is 0, then one of two things occur. If you're alive, you won because you caught all the cats. If you're not alive, you lost because the creepers got you. And then this is putting a button that says play again, and this is a very important call. This is saying to the scene manager, reload scene 0. So that's kind of here saying when the game is over, reload this scene and start from the beginning. So that's how we start the play again. Relaunches that one line. It's a very significant thing. That one little bit of code right here is saying restart the game if the user presses play again. This was an alternate way of doing it, application load level, and for whatever reason this ended up being the winning bit of code. I can't remember why we didn't do it this way. But fundamentally, in Unity 5 and also Unity 2017, the current version under beta test, this is a legacy way of doing things. As we can see, it works. It's still supported, but it's going away. You really shouldn't do it that way. There's a way better way of putting up displays, maps, scores, these types of things. We also didn't talk about sound. We didn't talk about animation. We didn't talk about 3D. But this is a good place to stop. And lastly, I'll say this. You may notice, I forgot to mention this, you may notice that in my editing environment, it's all black around here. And that's because you're looking, the reason is very simple. I didn't skin it that way. It's simply because this is what a pro license looks like. You'll see white everywhere. That accounts for that. The other thing is, my pro licensing only extends as far as Unity 5. So as long as they keep pumping out maintenance releases probably the rest of the year, I'll get 6 more months of maintenance releases, but then my pro license will only extend out to 5.6 whatever. They're not going to put out a 5.7. So so the moment I start making use of Unity 2017 for projects, it'll all be on standard licensing. Why? Because I looked at this price, Unity 3D, and we'll end it here. I know this is kind of a long bit of demonstration. I looked at the licensing for the Pro license, and $125 a month would be ridiculous because I've had this Pro license for many, many years, and I'm a little miffed that the permanent license is not permanent in the sense of permanent. If I could go, I would be basically prepaying $1,500 per seat per year, or $2,850 per seat per 2 year. Now, if I was making money from all of these endeavors, that would be one thing. But teaching, no, I'm not going to get on board with this this new per year subscription based scheme. If I ever come up with a game that makes money, that's a whole different story. I'd invest in a pro license in a heartbeat, but not with the teaching usage that I use right now. So there you have it. That's CreeperWorld's introduction to this, using a very, very old bit of code that you probably don't want to play with because it's so old. But it gives you a basic idea of how Unity works. This is Blind Man Bert signing off, and I hope you enjoyed this long demonstration.